This lesson is about measures of central tendency and a little bit more about box and whisker plots. So there are 3 different measures of central tendency. The first one is called the mean. Okay, that's the average. So on your calculator, when we get to do our statistics, this symbol is going to be X with a bar over it. So that means the average. So some notes about the mean is that it's sensitive to extremes, so it's high and low. So you might read that we read a lot about median household income. We use median, and not the mean, because if you have somebody that is earning billions of dollars, or they're worth billions of dollars, or they earn millions of dollars a year, that's gonna, if you put them into the average, the mean, you're gonna throw off kind of where the center is. So if you look at a simple example, if you have 2, 2, 2, 3, 12, the center, if I add up 2 plus 2 plus 2 plus 3 plus 12 and divide by 5, because there's 5 in the data set, it's going to be 4.2. So these numbers are all less than 4.2. So this 12 is kind of throwing it off. So it's sensitive to the extreme high and lows. The median is the middle number of the data set. So if there are 2 numbers in the middle, then you take the average. So just make sure to order the numbers. I see people making mistakes because they don't order the numbers from least to greatest. Actually, if you do it from greatest to least, it's still going to work, but you just want to put them in order. The mode is a number that occurs most often. So mode would be like, tell me, let's figure out the most common eye color in our class. I'm gonna have values that are actually not numbers, so I wouldn't use the mean or median to figure out what our tendency is for eye colors. A data set can have no mode or 2 modes. If it's 2 modes, it's said to be bimodal. And then we're going to do a box and whisker plot. So in a box and whisker plot looks like this. Right here is going to be your median. This is Q3, the third quartile marker. This is Q1. And the endpoints represent your minimum number in your data set and your maximum number in your data set. That's what we call the 5-point summary. So with your box and whisker, you always need to make sure to draw some type of a scale. So common mistakes are people will not even draw a scale. They'll just make their box and whisker. They'll just draw their box and whisker and then put a scale at the bottom. But you need to make sure that you put a scale on the bottom or on the top. So 10, 20, 30, 40, 50. And then you plot your 5 data summary. And then you connect the whisker, you make the whiskers and then the box. So in a box and whisker, 50% of the data lies between the first quartile marker and the third quartile marker. So 50% of the data lies between here and here. 25% of data is in each of these. So this is 25%, this is 25%, this is 25% of the data, and this is 25% of the data. So depending on the shape of your box and whisker, this could mean that the data is clustered together right here. Then over here, it could be more spread out and more spread out. So on your calculator, I'm going to link a video to do it on your calculator. But what you're going to do, the first step is when you're doing a box and whisker plot, is you're going to go to Stat. Then you're going to press Edit. And then you're going to want to put this data in your L1. So in my L1, I'm going to write in 4, 5, 6, 7, 8, 3, 4, 5, 6, 9. So I put all of these data in here. Then after you put that into L1, you're going to go back to Stat. So press Stat again. then you're going to go slide over to calculator, and that's at the top. And you're going to choose 1 var stats. Okay, that stands for one variable statistics. And enter through. So you're going to get your x, that's your average, so 5.7, that's your mean. And also I'm going to look at, if you scroll down, you have minimum, you have min x. Well, min x is 3, that's the minimum number. Q1 is 4, so it's already given you your quartiles. The median is 5.5. Your Q3 is 7. And your max is 9. So that's how you get your data. So what you'd want to do is when you want to make a scale, so our scales, we're going from 3 to 9, so I'm going to go 0, 10, 5. And then I'm going to plot this 5 data summary. So the minimum is 3, the Q1 is 4, the median is Q5, or 5.5, the Q3 is 7, and the max is 9. So now I can put my whiskers and then the box. Okay, example 1, looking at this box and whisker plot right here, what is the interquartile range? So that might be a new vocab word that you don't remember from geometry, but the interquartile range is going to be Q3 minus Q1. Its range, which is high minus low, and the interquartiles are right here. So for Seattle, it's right here and here. So I'm going to subtract 69.5 minus 51.5. So 69.5 minus 51.5 is 18. So the range is 18, interquartile range. Which city has the greatest median? So I'm going to look at the medians of both. Here's the median, here's the median, here's the median. It's San Antonio. So San Antonio. All right, so I'm going to create a box and whisker plot of this in my calculator, and you should follow along too, so you should press pause and put this in your calculator and see if you can go to stat, edit, L1, and then stat, calc, linear, first variable, linear statistics. So I put that in my calculator, and now I'm going to make a scale. So I'm going to go from 0 to 70. So 10, 20, 30, 40, 50, 60. Not perfect. Okay, but 13, so this is 10. So 13 is going to be right here. 20, 37.5, 52, and 64. So I make my whiskers and the box. Now, my range, you might remember from earlier statistics, my range is the maximum minus the minimum. So I'm going to do 64 minus 13, and I get 51. So the interquartile range is Q3 minus Q1. So Q3 is 52 minus Q1 is 20. So it's going to be 32. So one reason that I want my interquartile range is it helps me statistically find out outliers. So previously, maybe you were just, the definition of outlier was a number that was either very high or very low, or not next to any other numbers in a data set. So actually we're going to quantify it. We're going to put in a number on what exactly is an outlier. So you can definitely have more than one outlier. And the formula to find the outlier is, this is kind of demonstrating what an outlier is, but the formula is take your Q1 and subtract 1.5 times the IQR, which is the interquartile range, and then take your Q3 and add 1.5 times the IQR, and anything that is greater than this number or less than this number will be an outlier. So I'm going to use this data set up here, and my IQR is 32. So I'm going to do my Q1, which is 20, minus 1.5 times 32. So I'm going to do 20 minus 1.5 times 32, and I'm going to get negative 28. And then I'm going to do my Q3, which is 52, and I'm going to add 1.5 times 32. So if I do 52 plus 1.5 times 32, I get 100. So anything that is, that's what I'm doing right here for example 4. Anything right here that is less than negative 28 or greater than 100 will be an outlier. So looking at our data set, are there any outliers? Was there anything greater than 100 or less than negative 28? No way, because there's not a negative number and I don't see a triple digit here. So I would write no, there's not any outliers. And what you want to do is make sure you're showing your work right here. So I'm going to give another 5-point data set. So we'll say our min is 2. Our Q1 is 45. Our median is 50. Our Q3 is 52, and our max is 60. In order to figure out the outliers, I need to figure out what the IQR is. So the IQR is 52 minus 47, which is 7. So I'm going to do Q1 minus 1.5 times the IQR. And then I'm going to do Q3 plus 1.5 times the IQR. So Q1 is 45. So 45 minus 1.5 times 7 is going to be 45 minus 1.5 times 7 is 34.5. And then Q3 is 52 plus 1.5 times 7. So 52 plus 1.5 times 7 is 62.5. So if your number is less than 34.5 or greater than 62.5 in your data set, then it is an outlier. So really you can have more than one outlier. So we know already that 2 is an outlier, but maybe there's 3 in the data set, maybe there's a 4, maybe there's a 30. Those are going to be outliers.